Good afternoon. I'm Ece. I'm one of the PhD students of Safe Levees project. Today I would like to talk about the levee monitoring using satellite technology. Okay. So as we all know, and history also shows us that flood defense failures are rare events, but when they do occur, they lead to significant amount of damages, such as large number of fatalities and substantial economic losses. And not only the conditions relevant to these failure mechanisms are uncertain, but also the uncertainty in levee-related models are high compared to other structural models. So therefore there is a need for better calibration and validation of these models, or in other words, a better understanding of their uncertainties. So in this context, Safe Levees aims to improve the reliability of flood defense systems, as Myron explained before. What's my role in this project? I'm the work package 1. My main aim is to improve the understanding of levee failures and their underlying factors. But today I would like to give an update about exploring the use of satellite technology in levee monitoring. So, levee monitoring is one of the most essential issues in achieving the demanded safety level. But current inspection methods are challenging, especially in delta and coastal areas. They are mostly subjective and infrequent. If you look at our case, the Netherlands have 70,000 kilometers of flood defense systems, which require to perform their safety assessments and monitor their stabilities. And as we can see from the second map, half of these primary dikes do not meet with the required safety level. Another example, failures in Germany, 2002-2013. We saw that breaches happened at the locations that were safe according to the conventional stability computations. So at this point, we asked ourselves how we can develop and use advanced technologies to make the right decisions in the future. What can be our contribution in this field? And therefore, we decided to explore the use of satellite radar interferometry to monitor the levee deformation. And this technique may complement the existing approach with an innovative, frequent, and cost-effective way, because it provides millions of observations from 92 till today with a wide aerial coverage all around the world, 7 days, 24 hours, monitoring with a high measurement accuracy in millimeter level. We can obtain the measurements with a reasonably low cost. And the measurements can be obtained from 4 till 35 days. So the technique is not new. It's a very well-known geodetic technique to monitor surface displacements such as buildings, railways, roads, and natural movements. Also, there are some studies on levee monitoring, mainly leading by remote sensing department of our university. But these studies are mainly focusing on small case study areas, and they use only one-fits-all approach, which is they don't consider the levee conditions or behavior. So what we are doing now, we are working on a nationwide levee deformation monitoring in the Netherlands with satellite imagery to check whether we can have a continuous monitoring for levees and use these results as a potential indicative for early warning systems, and how we can study the deformation in different directions, what is the quality of the measurements, and how we can interpret these results for safety assessments of levees. And as a second step, we would like to focus on an area that failed, that we know that it failed, and how it deformed before this failure date, and what was the long-term deformation behavior of that location. But it's the second step. So for the Netherlands, we're using 5 different satellites for different periods from 92 till today, with different repeat cycles. And I would like to show some examples from the portal that we created. But I have to use one because I need the internet. So the main aim is to complete this map for the Netherlands, but I only uploaded. Yeah, okay. I only uploaded the 2 case study areas here to show you, not to. So I'm zooming in Myron Island now because we have high resolution satellite data from this location. From every 11 days. So if we zoom in on the dike, we can see the points. So for every point, we have deformation time series, as we can, one of the location at the point that I clicked on. So we can have the time series of the deformation, like on x-axis time and y-axis the deformation in millimeter. So when I move, I can see the deformation of this specific point by time. And also we have, for example, for this point, we have 3.6 millimeter per year deformation for you, and the quality of the measurements, and the height of the dike, etc. The kind of informations that we can have, so we can walk on the dike and have the time series of each point. So we also have the we have also Zeeland. It's a bit slow, that's why I only upload 2 of them. We have also Zeeland for the deformation monitoring. So we can go back to the presentation. Okay, perfect. So another question that I always receive, what about horizontal deformation, what about vertical deformation? So we also focus on that topic. For Myron van Damme, we monitor the area, we obtain the measurements in line of sight direction here, and then we can, I don't explain all the methodology because it's quite long, but we can also obtain the vertical, horizontal, and normal and transversal deformations with a certain amount of coherent value or standard deviation, of course. So as I said, we focus on different areas, for example, Flevoland, Marken, Harlingen, Zeeland, Myron van Damme. So we monitor these areas, okay, we are okay with that, but we have to move on from this one-fits-all approach to the adaptive methods, using all available information for the dikes, because with the current methods, we remove almost 90% of the points, considering that they're noisy. But actually, if you consider the dike behavior, like, for example, non-linear behavior of the dike, and the orientation and the coverage, we can have much more points, and we can deal with the noise. So, again, the use of interferometry for management practice of levee is controversial. There are a lot of questions about the application of the methods. But we have to clarify that too high expectations can lead to disappointments for now, because we cannot obtain millimeter, we cannot say we have millimeter precision anywhere and anytime. That's not true. We have to see the method as another tool in the toolbox, but for now, because technology is changing. When last year in this period, we were obtaining the measurements every 11 days, but today we have the measurements every 4 days. So for now, it's another tool, but in the future, using all three profitable characteristics, we can have a good method to monitor the dikes alone. So conclusion, we concluded that satellite technology can complement existing monitoring methods. So we would like to improve our methods for the dike, considering the dike conditions, and to be able to have a continuous deformation monitoring system to use as an early warning system and interpret these results. And I didn't talk about that part, but this is the second part of my PhD. I'm in my first year now. And in the coming years, we would like to focus on investigating the levee failure patterns and what are the underlying factors and what are the interrelations between different failure mechanisms using statistical analysis of historical failures using our database to be able to contribute to the existing approach for assessing levee safety. Thank you.
Thank you. Questions? Dan is er ook nog ruimte voor één andere. Oké.
I'll introduce myself properly this time. Steven Olie from Wetskip Friesland. Is it possible to measure water levels with satellite?
There are some methods to monitor water levels as well, but not specifically this method. This method cannot, because we are using signals to get scatters from the surface, and we cannot get back a signal from the water using this method. But there are other methods to monitor. They're using also for flows and maps.
Ronald Brinkgegeven. I was wondering, especially in the tidal areas, what are the daily variations of displacements compared to the trends that you see over a longer time? So
that's another topic that we would like to focus on, but I didn't talk about that part much, because there are some conflicts about this deformation monitoring and in the correlations, this hydraulic boundary conditions and stuff, so I didn't talk about that, but we would like to focus on that topic as well. And the thing is that tidal changes happens in like every 12 hours, right? So we monitor the dikes every 4 days. So minimum.
Not at the same time. Like
yeah.
One time high level, one time low level.
Yeah, it could be. Yeah. That's the second step. But we are now focusing on the monitoring part to be able to have good results and then interpretation of the results, of course, for boundary conditions, for example.
Thank you.